looks like. So we are going to look at characteristics. Here is characteristic number 1. I was going to highlight it, but I was afraid that pulling my highlighter might wreck the whole computer. So I'll underline. Non-permissible values, they will either become wholes or vertical asymptotes. They become wholes if they disappear after you simplify, then a non-permissible value becomes a whole. If they do not disappear, a non-permissible value will always be a vertical asymptote on your graph. So, here's the first one. You will always factor things completely to be able to find out what would make you divide by 0. Can you see that this one's already factored? And if you plugged in either positive 3 or negative 1, you'd be divided by 0. The factor on the top is x plus 3, so nothing simplifies, right? You can't just cancel out the 3's. In order to cancel out a factor, it has to be exactly the same. And adding and subtracting groups things together. So nothing cancels here. Both of these non-permissible values will become vertical asymptotes. So you would have, if you have a red pen, add a dotted line here, add a dotted line here. You would have one at -1 and one at 3. If we look at what type of graph this is, can you see that you have a parabola on the bottom and a line on the top? In other words, the degree, the parabola is bigger than a line. Anytime the degree is bigger in your denominator, you will always have an asymptote at 0. That was our group 3 that we looked at yesterday. If you have a non-permissible value, like in the second example here, can you see that we have a factor of x minus 3 on the bottom, and it's identical with the factor of x minus 3 on the top? You would now get a simplified equation of y equals x plus 1. That tells you you are going to have a whole at, the non-permissible value is 3, you're going to have the whole at 3 comma something. Right? This is the non-permissible value. And you can find the y value of your whole by plugging the non-permissible value into the simplified equation. I'm not allowed to plug in 3 into this equation, because then I would get 0 on the top and 0 on the bottom. I'm not allowed to have 0 in my denominator. However, when I simplify, and here is my simplified equation, I would be allowed to plug in 3 there. If I plug in 3 for x, I would get 4 for y. And that will be the coordinate of the whole. So you would graph y equals x plus 1, a straight line, but now it would have a hole in the graph. And this is what it would look like. So you use your skills for graphing lines from before, but just add a hole in the graph. That is characteristic number 1. Now, sometimes you get a situation Is this one even given to you? Yeah, they have this one. They have the note, but I don't think they gave you.
No, there is no graph.
There's no graphs. Okay? So in this one, do you notice that one of these x minus 3's will cancel out with one of those? Normally when something cancels out, it would be a whole. However, it cancels out, but the non-permissible value is still there. So because it's still there, it will still be a vertical asymptote.
Sorry, I just got something to say.
Okay, thank you.
Yep.
But those ones, situations like this, they don't come up very often. All right. I'll make this bigger so that you can see it better. First thing I'd like you to do in example 1 here is write down the following steps for graphing our rational functions. Should I zoom in even further? Is that still too small? Or is it okay? Mira, you're at the back. Can you read that or should I make it bigger? Because I can make it bigger and then I'll just scroll down later. Yeah, we'll still be doing work on this one. So if you want to write these steps, maybe you write them on page 106, because you got a lot of space there. We're going to take those, put them off to the side so we can still see them, kind of. And we're going to look at how do we go about graphing each of these. I know this question just says to predict the vertical asymptotes, but we're on the test, the only thing they're going to be asking is, can you graph the whole thing, including labeling your asymptotes? So we're going to practice graphing all of these completely as we go along. So in A, step 1 that you're going to do with all your graphing rational functions is factor it completely, both your numerator and your denominator. So on the top factors as a difference of squares, x plus 5, x minus 5. Are there any factors that are exactly the same? Yes. Those cancel out. And our new equation, which I'll put a green box around, is just y equals x minus 5. So we factored completely and simplified. Number 2, list any non-permissible values. So I'm going to say, were there any non-permissible values? Minus 5 is not allowed, so we go x can't equal minus 5. And then every non-permissible value will either be a whole or a vertical asymptote. If it cancels out and goes away, can you see that that's what happened? That means it's going to be a whole. So we're going to have a whole at minus 5 comma something, and the y coordinate you find by plugging into the new equation, minus 5 minus 5, minus 10, that will be your whole. ourselves, because sometimes you look back at your notes like, where did I get the minus 10 from? So there's a little note there that once it's simplified, you can find the whole by plugging it in. That point is normally part of that line, but since it's a non-permissible value, we have to take it out in this situation. Okay? Now in our steps are graphing rational functions. Factor completely, we've done that. List the non-permissible values and determine if they're wholes or vertical asymptotes. We did that. And then we hit the green note. The green note there says, if there's a hole in your graph, if there's a hole, you graph the simplified equation. That note's in green. The simplified equation is in green. Do you know how to graph y equals mx plus b? Yes. You do not even have to do any of these steps, 3, 4, and 5, because when you go to graph this, it's a line. You already know how to graph a line. How do I graph a line? Well, I start with my y-intercept, which is at minus 5. My slope is 1, so up 1 over 1, up 1 over 1, up 1 over 1. And I have to include 1, 2, 3, 4, 5, 6. I have to include right here a circle at minus 5, minus 10. That's the hole in my graph. This is all that would be needed for part A. So sometimes in the steps, we didn't have to figure out horizontal asymptotes or oblique asymptotes because after it's simplified, it was something we already knew how to graph. I'm going to erase part A once everybody is ready. Are we good? Yes? You like almost? So now we'll look at part B. Again, it says factor completely. I can factor out a common factor of 2 out of the top. Nothing simplifies in this case. So we factored it completely. Now we go to our non-permissible values. In this case, x can't equal 2, because that would make you divide by 0. And since it doesn't cancel out, we have a vertical asymptote at x equals 2. Okay? Now, we don't have a simplified equation, so we do have to go through steps 3, 4, and 5. This is a line divided by a line, in which case the degree is the same on the top and the bottom. When you had the same degree on the top and the bottom, you always had a horizontal asymptote. These are the ones, when x gets really, really big, you could ignore the other numbers, just look at the 4x over x, so your horizontal asymptote will be at y equals 4. Step 3 is done. Step 4, it says, do all of your intercepts and any other nice points. And it says 1 point in each section. So I'll explain what that means right now. If we start graphing this, we could draw our asymptotes on it. We know that we have an asymptote at x equals 2. And we also know that we have a horizontal asymptote at y equals 4. This is our starting point. The easiest thing to find is your y-intercept. A y-intercept is always when x is 0. So if we plug in 0 for x, the mental math is not hard. You'd get plus 2 over minus 2, which would be minus 1. That would be a point on our graph. We know that when x is 0, y is negative 1. For our x-intercept, our x-intercept is when y is equal to 0. Now something really cool happens when y is equal to 0 in a rational equation. I'm going to rewrite my rational equation, which was 2 times 2x plus 1. There's the factored form divided by x minus 2. Really what you have with a rational equation is a fraction. Can you give me an example with just whole numbers of a fraction that's equal to 0? Tell me a number in the numerator, a number in the denominator that's equal to 0. What would be an example of a fraction that's equal to 0? Something over something equal to 0. Give me possible numbers. What would be on the bottom? Can we divide by 0? No.
Just the 0 is.
But could you have a 0 on the top and an 8 on the bottom? Could I have a 10 on the bottom? Could I have anything on the bottom? 7. But the top would have to be 0. Now we can't have 0 on the bottom because that's our non-permissible values. But if you want a fraction to equal 0, does it make sense that the top has to be 0? So I have a lot of students in this section who just look at the factored form and can already see that this has to be negative a half. Because it's already factored. If you wanted to do this algebraically, the first thing I would do is say, multiply both sides by x minus 2. Can you see that that would cancel out the x minus 2? And on this side, you'd still have 0. Which is just basically saying the bottom doesn't matter. It's just where the top of the fraction is equal to 0. And it's already factored, so you could just say in your head, oh, it has to be negative a half. But if you wanted to, you can multiply it out, move it over, solve for x, and get x equals negative a half that way as well. So if I label that point on my graph, I have negative 1/2, comma 0. I have 0, negative 1. I have 2 points. And the instructions say, do your intercepts, we've done that, and nice points, 1 point in each section. And what I mean by 1 point in each section is your vertical asymptote breaks your domain up. Can you see that your domain is either less than 2 or bigger than 2, and that asymptote breaks down? So when we need at least 1 point in each section, you need at least 1 point to the left of the asymptote and at least 1 point to the right of the asymptote. You see we already have points on the left side. We do not have any points in the domain to the right of the asymptote. So as far as a nice point goes, what's a value bigger than 2? Maybe I try 3. What would happen if I plug in 3 for x? Can you do that mental math? 14 divided by 1?
Yep.
3 comma 14. Okay. This isn't the nicest as far as where it is on the graph, but I could go up 3, 5, 10, be about here. 3 comma 14. And that's all you would need is 1 point in each section. Because the very last thing it says is you draw your graph towards your asymptotes. So obviously these points are going to connect, and then if it goes towards the asymptote, it would have to go this way and this way. Once you have a point in this section, it would have to look like that if it went towards the asymptote. Some rules that are very important. Since you found the x-intercept, that's the only x-intercept that can exist. If you add a new x-intercept, you know you've made a mistake. Sometimes you're going to be tempted to add a new x-intercept, but it's not allowed. Okay? You just need 1 point in a section, because can you see that this is in this upper right hand? And then if it has to go towards the asymptotes, those are my only options. And this would be our final graph. So we draw our asymptotes first, find some nice points, and then your graph gets drawn towards the asymptotes. The rules itself aren't too bad. Okay, I'd like you to circle question number 5.